Elm has a few different flavors you can use depending on what it is you want to build, and today we're going to have a look at each one of them. I'm going to be building off the code from the previous video, so check the description for that link. Let's get started. The first Elm flavor is also the simplest, and it's called Sandbox. Like the name suggests, Sandbox is a way of creating really limited Elm programs. Basically, all you can do is react to user input, like we're doing here. I'm clicking the button and updating the model. I can't make HTTP requests or do any JavaScript interop, and I can't pass flags to the Elm program when it initializes. If you don't know what flags are, don't worry, we will get to that in the next section. Looking at the main function, we can see that we are handling an init, which runs when the program initializes. The update, which handles our messages like button clicks and updates the model or state, whatever you want to call it. And of course, the view, which takes that model or state and renders what we see here. In terms of usefulness, it's quite handy for prototyping or just trying things out. But again, very limited, and that's because our update function only creates a model. It doesn't allow us to create commands or effects, which is what we would need for something like a HTTP request or a DOM query. The next Elm flavor that we're going to check out is called Element, and this is perfect for when you already have a website and you want to sprinkle in a little bit of Elm goodness. Element also gives us a few extra powers that we're going to explore, so let's check it out. Before we change anything, I'm just going to quickly add the type annotations to the functions so we can get rid of some of these warnings. With that out of the way, all we need to do is change Sandbox to Element, and immediately you can see the Elm LSP is yelling at me. What this compiler error is saying is that the Element function wants us to handle a few more things than we currently are. You can see the error mentions we are expecting this type of function, but we found this type of function, and also we are missing the subscriptions field, which has this type of shape. In a nutshell, our program will not compile until we handle these correctly. Let's start with the init function. If we jump to definition, we can see that the init function takes an argument of flags and returns a tuple of model and command message. The quick and dirty explanation of flags is that it's a value that comes from JavaScript when we initialize the Elm program, but we will dive deeper into this in another video. For now, we aren't passing this program anything from JavaScript, so let's just ignore it. The model command message tuple refers to the model being the running state of the program, and this new thing, command message, which is what grants us the power to do interesting things such as query DOM elements and make HTTP requests. So let's actually create an init function and let's add the type definition so it's very clear what we are doing. For the arguments, like I mentioned earlier, we are not going to handle flags, so we can just put an underscore here to say, I know there's an argument here, but I don't care about it right now. The return value is a tuple of model, which in our case can remain an int of 0. And we are not going to create any commands right now, so we can just use command.none. Let's add this init to the main. Let's jump back to the element definition and have a look at update, and it looks like it takes some message and some model and returns a tuple of model and command message. Back in our current update, we can see that we are actually almost there. We are taking a message and model, but just returning the model, which is an int. So let's go ahead and fix that type definition to be model command message tuple. Now let's actually return what our type definition says we are returning. And to do that, we can simply wrap what we currently are returning in parentheses, put a comma in between, turning it into a tuple, and once again add a command message of command.none because we are not interested in doing any fancy stuff yet. Let's jump back into the element definition and sort out our view function. And I'm seeing here that the view function takes a model and returns some HTML of message. Looking at our current view, we can see that we are taking a model and returning HTML message, which means we are already doing what's required. Once again, heading back into the element definition, we have this new kid on the block called subscriptions. We can see it takes some model and returns a sub or subscription of message. Subscriptions let us subscribe to certain browser type stuff like window resizing, animation frames, keyboard events, and JavaScript interop and things like that. Again, worthy of a video on its own. So we will satisfy this requirement, but we are not going to go into it on this one. Let's follow the same pattern and create a separate subscriptions function with a type definition of our model and returns sub message. I'm just going to ignore the argument and return a sub.none. Much like command.none, we're saying we don't want to produce a subscription message right now. And no more errors. We have a compiling program. Nice. Okay, so big deal. We have basically the same program we had last time. Whilst that's true, Element does grant us the power to do lots more, and I'm going to show you a very simple example right now, but rest assured, I'm going to dive way deeper into this in future videos. So just to show a quick example, we are going to react to the button click as we have been, but as well as increment or decrement the model, we are going to set focus on the opposite button. So if we click the plus button, we will increment the model by 1, but also set focus to the minus button and vice versa. Simple, pointless example, but still something we couldn't do with the Sandbox program. Let's start off by giving each button an ID, so we have something to target. We'll call this one increment, and this one decrement. The place we'll be reacting to the click is in the update, and we can see we are already reacting to the click because we are incrementing and decrementing the model. I'm going to create a let block and create a function called focus decrement, and the thing we'll be returning is a command message. The syntax here might look weird if you've never used Elm before, but essentially what's going on here is the focus function returns a task, and we are then attempting to run this task. If it's really important for you to know if the task was successful, then you're going to want to handle that result. For our purposes, we actually don't care. We can safely assume that it's going to work. So let's ignore the result and just respond with a message called noop. This message doesn't exist yet, so let's add it to our message type and handle it in the update by returning the model as is and command.none. The fact that we are returning the model as is and command.none in the update function for noop is the equivalent of doing nothing. Okay, so now what we can do is instead of return a command.none from the click, we actually have a command we do want to run. So let's replace it with our focus decrement command. I'm going to quickly do the exact same thing for the decrement, but instead target the increment button ID. And let's try it out to see if it worked. Yep, I clicked the increment button and now I'm focused on the decrement button. Awesome. A pretty silly example, but hopefully you have an understanding of where you can take this from here. Next up, we're going to explore the document program. Document expands what Element does, but it's more concerned with the entire page rather than an individual element on that page. For example, it lets you control the title and body of a HTML document. Let's jump back in there and I'll show you exactly what I mean. I'm going to just replace element with document and let the compiler errors tell me what to do. Okay, so we have set compiler errors showing up, and what it's saying to us is that the view function is not returning what it is expecting. If we jump to definition, let's have a look at what the view function of the document looks like. View takes a model and returns a document. So the first thing I'm going to do is probably annotate the view function in our code. Then I'm going to jump to definition for document and see what that looks like so I know what to return exactly. Okay, it looks like document is an object with two fields, title, which is a string, and a body, which is a list of HTML message. So let's return just that from our view function. For body, we can wrap what we currently have in square brackets, turning it into a list. And also take note of this title value, which we've just added. We're going to set it as hello. Once again, we have no errors. Awesome. And if we go to the browser, we can see that the program is compiling and the title on the browser tab reflects the value we used in the code. Document is the right choice when you want Elm to take over the rendering of the page. This isn't something you would typically use if you want Elm to play nice with something that already exists. That's a job better suited for Element. The next program is called Application, and it takes Document to the next level. Now we're going to get the full single page application experience here, so we're going to have to deal with a router. We get a lot more power, but we also get a fair bit more complexity. Let's jump back into the code and have a look. Just like before, let's go ahead and change Document to Application, and sure enough, we get the LSB telling us something's up. There are a few differences with Application and Document, first of which is the arguments that are passed to the init function. If we jump to definition, we can see that init is not only getting the flags argument, which we are currently ignoring, but we also get a URL and key argument. Let's go ahead and annotate the init function to match this. When I type URL, the LSP isn't giving me an action to import the URL type. The reason for that is in our elm.json file. As we can see here, the URL package is listed as an indirect dependency, and if we want to actually use it, we will need to include it into our direct dependencies. Now, you might be tempted to just move this yourself, but it's much better if we ask Elm to do it for us. From the command line, we type elm install elm/URL. You can see it knows it's listed in the indirect dependencies and asks us if it's okay to add it to our direct dependencies, which is what we want. Let's put Y for yes. Back in our code, the LSP is now giving me the option to import this type. Let's also not forget to add our key type. Just to get things compiling quicker, I'm gonna ignore the URL and key arguments, just like flags, for now, but we are going to come back to this. That should be the init function sorted. Jumping back to the definition, we can see that the view, update, and subscriptions functions all look the same, but we have some new stuff to handle here. We have a onURL request and onURL change. Let's create individual functions for these. Starting with the onURL request, which takes a URL request and returns a message. We're going to ignore the argument and we need to return a message. At the moment, we don't really want to do anything, so we can use our no-op message for now. This onURL request function gets called when a link is clicked, telling our program that the user wants to change the URL. This is handy because it lets us do things like save the scroll position or maybe persist some state to local storage before the URL change. Let's now sort out the onURL change function, which takes a URL and also returns a message. Same deal as before, we are going to ignore the URL argument and just return the no-op message for now. With that, everything should compile, and it does. Awesome. I hope I was able to give you a better understanding of the different types of Elm programs that you can build. For simple stuff, stick with Sandbox. If you want to add Elm to an existing web application, then Element's a good choice. For a single static page, then Document is probably what you want. And for that chunky SPA, then Application is what you're going to choose. In the coming videos, we're going to fill in the gaps that we glossed over on this one. So I hope you're able to join me on those. Thanks.